Hi guys, it's time to talk about prisms. What is a prism? It's very simple. Okay, a prism is a polyhedron. In other words, it's a three-dimensional object with polygons on the outside. Okay, so we start with a polygon, any kind of polygon, okay, and we make another polygon parallel to the first polygon. So polyhedron made of two parallel congruent polygons connected by quadrilaterals. For example, let's suppose I have a triangle, and I'm going to make part of this a dashed line because I'm going to make a prism out of this. And there's that, and there's that, and there's that. And I have another triangle here, which is parallel. Oh my goodness. I know, I'm such a bad artist. Anyway, the triangle on the bottom is parallel to the triangle on the top. Okay? And these things connecting, these are, in this case, they're rectangles that are connecting these two. We've seen these before. This is a triangular prism. And I'm going to show you a web page that really does a lot better job of showing you what. Now, the nice thing about the internet is if you type in prism, you can see all kinds of cool stuff. Like this is a triangular prism. Okay? These are triangular prisms. You see the red images, or the red triangles there? Those are the bases, okay? Blue is the base here, and yellow and orange are the lateral faces. Here we have a couple of different, you see in the yellow, you've got a pentagon, a regular pentagon, and those dotted lines, if you put sides, lateral faces all the way around there, you would have a pentagonal prism, they call it. So let's take a look at a couple other things here. This is important here because you notice on the bottom it said pyramids. How many bases do they have on the pyramids? There's only one base there, right? On the top you have prisms because there's, except that middle one I don't think is a prism for our purposes. But on the top you have prisms because you have two bases. You know, one on the top, one on the bottom. And so before we get too caught up, let's go back to the definitions, and we'll talk about some more definitions. Okay? So the prism is a polyhedron made of two parallel congruent polygons connected by quadrilaterals. And the reason I say quadrilaterals and not rectangles is because sometimes we have what we call an oblique prism. Okay? And we'll talk about that in a second. Anyway, we got two bases. We got a base here, okay, base, and on the bottom you have a base, okay, and then you have lateral faces, okay. This is a lateral face, so is this, lateral face, and then you have lateral edges, okay. These are lateral edges, okay? Lateral edges. That's what those are. So on a right prism, okay? On a right prism, that's kind of like a right triangle, okay? But a right prism has all the lateral faces are all rectangles. Okay? the lateral faces are all rectangles. For example, this appears to be a right prism, right triangular prism, because it looks like all the lateral faces, all three of the lateral faces, are rectangles. Okay? Now, an oblique prism, I'm going to go back to that web page I showed you a minute ago. An oblique prism is, here we go. Look at figure 1 up at the top there. You see figure 1? That's an oblique prism, because you see that one of these things is at least one of the lateral faces is a parallelogram, not a rectangle. So it's a parallelogram. So lateral faces are all rectangles. So an oblique prism is at least one lateral face is not a rectangle. All right? And now we're going to do another definition, and this is I'm going to have to clear the board for this one, because this is kind of like all right, let me see if I'm going to do my best. Back up a minute. I'm going to do my best to create a decent looking okay. And 1, 2, 3, and you notice I'm drawing straight lines now. I'm using my straight line drawing tool. Okay. Now I'm going to draw the back ones, and then I'm going to connect these, and then I'm going to make them into dashed lines, because I don't know how to make a dashed line yet on this one. Okay, so I'm just going to show you how to. Okay, you get the idea here. The back ones are dashed lines. Okay. Now, what happens if I make a diagonal from this point right here to this point right here? You see that purple line? That's a diagonal, okay? That's inside the prism. Okay? That's inside the prism, and I think it might be a little easier if I make some labels here. I got A, B, C, and D, and then on the bottom I have E, F, G, and H. And so that diagonal line is BH. You notice that B is on this plane, the top, and H is on the bottom plane. Or if you'd rather, you can say that B is on the back plane and H is on the front plane. It doesn't matter. The point is that the diagonal, and this is a definition, is a segment whose end points are vertices of two different faces. Two different faces of the polyhedron. Okay. And finally, we are going to write the diagonal of a right rectangular prism equals D equals the square root of length squared plus width squared plus height squared. Well, what does that mean? Well, it's just very, very simple. Suppose you have a right rectangular prism, okay, with the length equals 6, the width equals 4, and the height equals 5, okay? So how do you figure out the length of a diagonal in that right rectangular prism? Well, you just go the square root of 6 squared plus w squared is 4 squared plus h squared is 5 squared equals the square root of 36 plus 16 plus 25 equals the square root of 5277, and that is approximately equal to, get out my calculator here, and my calculator does not, there we go. Okay, clear. Square root of 77 equals 8.77. So approximately 8.77. So that's how you do a problem like that, and we'll talk more about this in class. Thank you so much.